Synthetic aperture radar (SAR) images are transformed into more intelligible optical images using an innovative generative model based on diffusion models. This novel approach addresses color shift issues by incorporating color supervision, ensuring accurate and reliable results. Experiments conducted on the SEN12 dataset demonstrate the model's superiority in both quantitative and qualitative assessments. The results showcase enhanced visual quality and improved interpretability of SAR images, making them more accessible for analysis and decision-making. The diffusion-based model leverages the power of generative learning to produce high-fidelity optical images, effectively bridging the gap between SAR and optical imaging modalities. By doing so, it enables the exploitation of SAR data in a broader range of applications, including those that rely on optical imagery. The incorporation of color supervision is a key innovation, as it mitigates the color shift issues that often plague SARTO optical image translation tasks. This results in more accurate and realistic optical images, which are essential for tasks such as land cover classification, object detection, and change detection. Researchers have developed a conditional diffusion model for transforming synthetic aperture radar (SAR) images into high-quality optical images. Building on recent advancements in diffusion models, this approach leverages SAR images as a guiding condition to improve fidelity and clarity. The model's architecture is founded on the diffusion model framework, comprising a forward and backward process. In the forward diffusion phase, Gaussian noise is progressively infused into the original image, whereas the backward process predicts the Gaussian noise given the transformed image. Notably, the model is enhanced with color supervision, utilizing SAR images to condition the generation process. This approach addresses the limitations of previous methods, which often struggled with color accuracy and object differentiation. By incorporating SAR images as a guiding condition, the model can better capture nuanced color variations and object boundaries, resulting in more accurate and detailed optical images. The conditional diffusion model offers a promising solution for transforming SAR images, which are often limited by their inherent noise and resolution constraints. By harnessing the strengths of both SAR and optical imaging modalities, this approach has the potential to improve a range of applications, from land cover classification to object detection and tracking. A novel model for translating synthetic aperture radar (SAR) images to optical images is introduced, leveraging a diffusion process with color supervision. This approach builds upon a denoising diffusion model, where Gaussian noise is transformed into an optical image guided by the SAR image. A color loss component is incorporated to ensure refined and consistent guidance throughout the model's operation. Experiments on the satellite SEN12 dataset demonstrate the model's superior performance compared to established benchmarks such as Cycle-GON, Nice-GON, CRAN, and S2O-DPM. Across key metrics including PSNR, SSIM, and FID, the proposed method outperforms these models, accurately learning and replicating the complex mapping rules intrinsic to SAR and optical image conversion. Visual analysis reveals that the model's outputs are more realistic and natural-looking, with clearer object delineation and improved color fidelity compared to GAN-based models. Notably, the approach exhibits substantial improvements in overall color reproduction and target differentiation when compared to the S2O-DPM model. While the model's slower inference speed due to iterative inference t-times is a notable limitation, future work will focus on accelerating the model's sampling speed. This research contributes significantly to the field of image translation, particularly in the context of SAR to optical image conversion, with potential applications in remote sensing, environmental monitoring, and surveillance. The authors present a comparative analysis of their proposed model's performance in translating SAR images to optical images, benchmarked against various state-of-the-art models including Cycle-GON, Nice-GON, CRAN, and S2O-DPM. The results are visually demonstrated through Fig. 3, where each column represents the translation output from a different model, with the last column showing the ground truth optical image.